Morning everyone. Myself Alagu Rashmi, Assistant Professor of AMCO Institute of Technology from IT Department. Uh, Today topic is here Unit 3 Mutual Exclusion. First, mutual exclusion. What is mutual exclusion? So, mutual exclusion based on the token based algorithm. First algorithm is here Susik-Kasami broadcast algorithm. So Susik-Kasami algorithm is here two types. First one is here token based algorithm, second one is here non token based algorithm. First one is here token based algorithm. A unique token base is shared among the sites. The sites is allowed to the critical section process is a token. The token process algorithm is a sequence number of inside the timestamped. It is used to old and current request. So example is a Susik-Kasami algorithm. So one site is echoed to the another site, the another site is response to the request message. The which process is a token send the request update the receipt for the request message. The request message when is executing the critical section, the sends the token only after the complete the execution of the critical section. So first explain the algorithm. First one, the requesting the critical section. First it requesting the site, it consider the site si, it does not have a token. Then increment is a sequence number or ni. So send to the request to the message all the sites. Thus receive the message and the sends the token. Algorithm executing the critical section, releasing the critical section. The element of the token array equal to the number of processor. So every site is token is not a queue. Abandoned is taken a queue. The queue is non-empty after the above update. Delete the top site and ID from the token queue and send the token in the indicate ID. Design issues. The algorithm must address the following the design issues. First, my question is how to distinguish the outdated request message from a current request message due to the variable message delay. A site may receive a token request message after the corresponding request have been satisfied. If a site not determined if the request message to token request is satisfied, which all the message. Solution for the first issues. A request message of the site sequence number. The indicate the request was the critical section execution. The critical section is keep a array integer. Is denote the largest sequence number is request message. Next one is here queue of the next site and the array of the integer is execute the most recently. After the critical section update, the corresponding sequencing number has been executed. Finally, the mutual exclusion is granted because only one token system and site hold to the token during the website. The requesting site enters the critical section finite time. Through the token request message site, each other site is finite time. Since here one of the sites will be token in a infinite time, site is a request will be placed the token in a infinite time. Next one here, performance. No message is needed to the synchronization delay is 0. The ideal taken of the time is request. The end message to obtain the token synchronization delay in this algorithm is 0 or t time. So you will consider the 4 initial size and none of the recursion. The Rn1, Rn2, Rn3, Rn4, Rn5 it is considered to the array and considered to the 5 websites. So first initially critical section all are 0. The token queue and array is updated the size the whole the token. So ellipse symbol is a token and token considers queue and the array. The request accepted to the token. So sequence number is request. The request called is outdated request. The request is accepted and replied the token. So see, site one is request message where is the site and the sequential number of the critical section. So after checking the request, all the site is RNI. So finally assume the initial state of the sites. So consider the all our sites, one is updated to the critical section. So after receiving from the sites, update all the sites queue token, hold the ideal and the request one is queue. So sites 5 sites send the token request to the top of the queue, as the sites one is the top of the queue and the site send the token to the site 1. So site 5 send to the token site entire into a critical section. So after executing the critical section, site becomes out the updates. So after we coming to critical section, to checks the all are the sites, the value from the J is condition, sites to whether the J is token queue, the notes the SIC remove the top queue token. Sites to update and the sites to take the queue is not empty and update the queue. So site 1 is update the queue and site 2 is token 1 site 1. Thank you. And then the next topic is here system model. And next topic is here system model, mutual exclusion. The interaction deadlock is here. What is the deadlock? Deadlock is a fundamental problem in the distributed system. The process may be request resource in any order, which the period end process. Sequence is a collection of resource and resources controlled deadlock occur. Compared to the distributed program, we composed the set of synchronization process P1 to Pn. The process do not share the common globally memory and communicate the passing the message over the communication network. They are following an assumption. The system only one resourceable source. Processor allowed to make only one resources. Each process utilizes the following resources. First one is request, use and release. The process can be two sets. First one is a running and one is a blocked. The running set is the process all the needed resources executing the ready section. The blocked set is a not ready section. Third part is a wait for graph. The wait for graph can be modulated by directed graph called a wait for graph. In a wait for graph, nodes are processor and they the directed edges from the process 1 to process 2. The system deadlock execute the direct cycle or the wait for graph. You consider the see this kind of diagram. You consider the more than the processor more than and then 4 sites 1, site 2, site 3, site 4. So all processor interconnected to the every one site. Thank you.